everyone. I'm Sakshi Kesharwal. I'm maths expert in askIITians. So today we'll be starting with the very new topic, and this is going to be a really tough. So try to understand. So today we'll be learning something. This is median and altitude is a part of your curriculum, just the definition, but there will be some extra things which I will be teaching you. So keep this in the mind because this is not in the part of any curriculum. Like they don't teach you in class 9, they don't teach you in class 10, but this is what happened when you give so many of Olympiads. These type of questions are generally over there. So you should know this thing. And later on, when you will be learning straight lines in your class 11, this will help you. Like this topic will help you. And mostly the geometry questions in your Olympiad are mainly related to this concept, right? So you should know what it is and what it is not, right? And you can do the practical of it and you'll enjoy the class. Okay, so let's begin with the class. Yeah, so I think so it's visible over here. It says that let's talk about median. What is a median of a triangle? The first point is that what is median of a triangle, right? So median of a triangle is basically what happened if you take any triangle. Basically median is a line. Median of a triangle means what? Median is a line. Median is not a point, right? So if you take a triangle, if you take any triangle, right? And if you take the midpoint of this line segment, I'm naming this triangle as A, B, and C. Let me make them dark color. Okay. Take triangle ABC. So I say that D is the midpoint of what beta? That is BC, right? So from the opposite vertex, if you join the line from the opposite vertex to D, if you're going to join this line, then this is called beta what? Median, right? Median, this is called a median, right? So what happened if you see in a triangle, can you draw others? Like you can draw the other like midpoint of B. AB will also be existing. So I'm making a single stroke. It means what? That AE is equals to what beta? EB. Now, if you're going to join this point, so this is going to be what? Again, a median, right or not? This is going to be what? A median, right? Now, if you take the other color, like I'll take some green color. Okay. Now, there will be an AC. Now, you take the midpoint of AC. I'm marking over here 3 strokes means what? And I'm naming this as what beta F. Now, can I say that AF is equals to what beta? AF is equals to what? FC. I said BD is equals to what? DC. Can I say this as 1 by 2 of BC, right? Similarly, AE is equals to what beta? EB is equals to 1 by 2 of AB, right? Can I say that AF is equals to what beta? FC is equals to 1 by 2 of AC, right? Now, if I join this point that is BF, so this will again be what? A median, right? Now, you might be thinking that median is always passing through, there will be a same point that they will be like intersecting all the 3 lines. Yes, they will be intersecting at the 3 lines and you can do the practicals of it. Right now, in the last class, we have learned that the length of the 2 sides of the triangle is always greater than the third side, right? So we say that this point where they intersect, it is definitely going to intersect. It has been practically proven. So this is known as what? So let's see what a median is. Let's see the definition. It says that over here, the median is the line segment. It is what beta? A line segment which joining the any vertex of a triangle with the midpoint of the opposite side. It is not necessary it is going to be perpendicular. It is not necessary. It is just the line that join with the opposite side. And what is the important point over here? Median divides a triangle into 2 equal parts. We will be doing this proving. So please try to write it all these points that median is going to divide the triangle into 2 equal parts. And we will do that the area of ABD and ACD will be what? That half part, and the half part will be doing later on, right? The areas are equal, right? Now, it says that over here, just see over here, what are the things written? It's written over here that every triangle has 3 median, that is AE, that is 3 median, right? AE, CD, and BF in the above triangle. So there's a triangle different and my triangle is different, right? The point where all the 3 median intersect is called as what beta? Centroid. So the main point is that you should know what the centroid, the point of, that is point of concurrence. I'll write like this. Point of concurrence, that is a point of intersection, or we say that the point of concurrence, we say where the more than two lines intersect, they said is said to be what, beta, point of concurrence. Let us suppose I drew this is point of intersection also, but if I pass the third line and the fourth line through this point, then this point is said to be what, beta, point of concurrence, right? So point of concurrence means that is a point of concurrence of all medians, that is of all medians, is called centroid, right? And centroid, I'll just write this point, that centroid is denoted by capital G, right? Oh, centroid, yeah. Yeah, it is denoted by centroid as G. Now, why G? Now, I'll tell you what is the fact. You know that if you take a pen and if you want to like a balance, everything, you know that everyone wants to be in equilibrium, right? So when you just like to try to adjust something around you, so what you do? You know that, I think so, you have heard about the center of the gravity or center of the mass, where if you're going to stay the put the things according to it, it will always be in a rest position. Otherwise, it will fall. Let us suppose if you want to like just put a pen like this. I cannot show you right now. Let us suppose you want to put a pen like this on a air. So what you do lots of adjustment, and at one point it get adjusted, right? At one point it get adjusted. When it get adjusted, it means what, it is in equilibrium, right? So that is what beta, every body has a center of gravity or the center point where all the mass is being concentrated. If it is not adjusted accordingly, then it will what, the body will fall. Now these are the some facts which you should know about the centroid, and I will be showing you also. Just see this. I'll take different color of marker. Orange color will work. Let me see. Yeah. Okay. Now, what are the facts? The centroid always lies inside the triangle. Now, I will tell you, whatever the type of the triangle you have, whether you have acute angle, right angle, obtuse angle, whatever type of triangle, centroid always lies in the triangle. Now, I'll give you, you can do the proving, you can do by yourself, and I'll be showing you later on, right? So, median divides the triangle into two similar triangles are equal in area. As I told you, right now, as I told you that area, that is, let us suppose if this is a median, right? If let us suppose I drew this point, this and this is equal. So I said that this area, I name this as A, B and C, and this is D. So we say that area of ABD is equals to what, beta? Area of ACD. This is what we learned. Okay, centroid is exactly the 2/3 away from the median. Now what happened when you have the centroid, right? So centroid is 2/3 away means what? Centroid divides the median in 2:1. So it means what? If you're going to divide, now I think so you have learned about ratio and proportion in the last class. So what happened? Let us suppose I'm drawing the figure over here. Let us suppose AD is median, right? Let us suppose AD is median, and this is what a median, right? This is a median, and let us suppose the centroid lies over here, right? So what happened? Let us suppose AD that is centroid divides the median in 2:1, right? So we say that centroid divides the median in 2:1. So this is your centroid in 2:1. So this will be what, beta? 2 part, right? And this will be what, beta? 1 part. If I say let AD length is equals to how much, beta? Let us suppose 9 centimeter, right? Then find AG length and GD length, right? So what will be the AG length and GD length? So what is this? Now total AD is what? 3 parts. Like, so 3 parts is equals to how much, beta? 3 parts is equals to what? 9 centimeter. So 1 part is equals to how much, beta? 3 centimeter, right or not? So 2 part will be equals to how much, beta? 6 centimeter or not? So AG length will be equals to what, beta? 6 centimeter, and GD length is equals to what? 3 centimeter, right? So what happened where the 2 parts lie? 2 part always lies towards the vertex, Now let us suppose if you have, I'll write with different color, so you just see over here. Now if you see that this is the centroid, right? So with the centroid, this is the 2 part, and this is AE is a median, so AO is a 2 part and OE is 1 part. Similarly, OC is 2 part and OD is 1 part. Now similarly, OB is 2 parts and OF is what? 1 part. So you try to learn yeah. Okay, so can I say that AO, I'm writing with AO upon OE is equals to what beta? OB upon OF is equals to what beta? OC upon OD is equals to 2:1. All of them are what beta? 2 parts, and this is what? 3 part, right? Now I'll show you one more thing. You just see over here. Yeah, just see. Over here, if you just see this, what is the centroid of a triangle? Now just see. Centroid, if you see that this is a triangle, right? Now this is what an acute angle triangle, because all the angles are what? Less than 30 degrees, like less than 90 degrees, right? Now let us suppose the centroid is lying inside the triangle. This is why I'm showing you, just to get the confirmation. Yes, the centroid always lies in a triangle. And how many centroid and how many medians does a triangle have? Median has, sorry, a triangle have 3 medians, right? So you just give a close observation over here like this. And if I just make like this, it looks like a 90 degree. Yes or no? Yeah, it looks like 90 degree. Yeah, I'll just make it short so that it look like 90 degrees, right? So this is what a right angle triangle, right? So still the median lies inside the triangle. Now what happened? Let me just make this an obtuse angle triangle. A triangle can have a maximum of 1 obtuse angle. So can you see that angle B is what? Obtuse right now. So still the median, still it's lying inside the triangle, right? So we say that a median, that is a medians, that all the 3 medians will be what? There will be a triangle have 3 medians. Yes, the point of concurrence of all the 3 median is known as what? Centroid, right? Centroid is basically lies inside the triangle always for all type of triangle. Third, what is the third thing I want to tell you? Third is what? That centroid divide the median into 2:1 part, that is 2 part toward the vertex and 1 part towards the what side, and median divides the triangle into 2 equal areas, right? If you just part this part and if you take this part, the area remains the same. Later on you will be learning that the centroid divides the area of a triangle into 3 equal parts. This you will be doing in the class 9, but I'm not going into the proving a lot, but I'm just giving you a hint, right? So these are the things which you will be learning out, right? Now let's coming out to what do you mean by hold on. Yeah. Now let's coming to what do you mean by altitude of a triangle, right? Now, what do you mean by an altitude of a triangle? Altitude means what? Just from the opposite vertex to the side, you drop 90 degree. Now, some of the students get confused that when you drop opposite side a 90 degree, it divides into 2 equal parts. No, this is very much specifically only in equilateral triangle, no other triangle, right? If you take any rest of the triangle, that altitude is basically the line segment made by joining the vertex and the perpendicular to the opposite side, and the altitude is the height if we take the opposite side as the base. Now, as we will be learning later on, maybe that is what is the area of a triangle. So area of a triangle you will be learning that is half into base into height, and where the height will be what beta? That is the perpendicular draw from the opposite vertex to the, that is from the vertex to the opposite side. If you're going to take any triangle, right? Take any random triangle. I'm just making such random triangle. Now let us suppose A, B, and C, right? Now from A, I drew this 90 degree. Now this 90 degree does not mean that it is going to be what beta? It is going to be what? It's not necessary that it is going to divide BC into 2 equal parts. Please make sure, I'm saying again and again, only this happens in equilateral triangle, no other triangle. And again, we'll be doing the proving in the class 9th standard, right? Now, this is what D. Now, from the B, I drew a perpendicular. This is E. Now, again, I drew a perpendicular from C, that is F, right? Now, we see that how many altitudes? Now, as I said, that is, as I said for the centroid, although centroid is what also a center of gravity. That is why it is word denoted by G, center of gravity, because the concentration of all the masses. Now what happens if you just want to balance a triangle? If I say balance a triangle, now if you put the balance on the center of gravity, it will definitely balance it out. Otherwise it will fall. It will fall. Let us suppose if you have a paper, right? If you see that this is a paper, if this is the center, if I'm going to just put it something, it's going to balance, right? it's going to balance. Right now I'm on my finger, it's not very specific, but if I'm going to put my finger over it, it will definitely fall. So anything, if you're going to balance it on the center of gravity, that is known as, on its, like the center point, that's where of the mass is concerned, that is known as what, center of gravity. And similarly for the triangle, it is called beta what, centroid, right? Now coming to the altitude. Altitude means what, that you draw only the perpendicular from the opposite vertex to the side. That's it. It is not necessary that it is going to bisect the opposite sides. Now again, we learned that uh, median, like we say over here, that we have three medians in a triangle. So how many altitudes we have in a triangle? We have three altitudes in a triangle, right? Again, now you will say that altitude means what, they make 90-degree, right? The altitudes form an angle of what, beta, 90-degree. There are three altitudes in a triangle, right? The point of intersection or the point of concurrence of the three altitude is known as what, beta, orthocenter. Orthocenter, right? Orthocenter, it is what called beta, orthocenter, right? So we say that the point of, that is point of intersection or concurrence. I will write the word concurrence, and intersection is already written over here. Point of concurrence of all medians is called orthocenter, right? Right. Now, what happened? Now I'll tell you the proper definition. Now, it is denoted by, denoted by capital H. That is H. That's orthocenter, right? Now, one more thing I will say. Right now, we have learned that the centroid, whatever type of the triangle you have, the centroid always lies on what beta? Inside the triangle. But here, the altitude is a very specific thing. The altitude, now you will see, I'm going to show you the figure. The altitude still does not lie on what beta? The altitude does not lie on what? Inside the triangle always. So I'll just show you this thing. Just hold on a minute. Now you just see this. Okay. Okay. Now just see. This is what over here. Just see. This is what a right angle triangle, right? So you see that this is an altitude, right? Hold on. Stop sharing. Hold on. I think I got a wrong link over here. This is an altitude. Hold on. Yeah, this is what I want to show you. I got a wrong thing. Okay. Just see this. Hold on. Yeah, can you see this? Now, this is an orthocenter, right? Now, this is what all the orthocenter, this point is known as what, orthocenter, and this is what all three altitudes, right? Now, ABC is what? A right, that is an acute angle triangle. So for acute angle triangle, you will see that it's going to lie on what? Inside the triangle we have just drew, right? Now, let's make this a right angle triangle, right? Let's make a right angle triangle. Mhm. Yeah, this is what a right angle triangle. So if you see in a right angle triangle, the orthocenter lie on the vertex of what, 90-degree, right? Now, what is the third thing we see? The third thing we see is that if you're going to make this an obtuse angle triangle, you see that the orthocenter is going to lie outside the triangle. Give a close observation. The orthocenter is going to lie outside the triangle. Now you see this is an acute, this is going to be right, and this is going to be what, obtuse. So we learned that the orthocenter, it's not necessary to lie inside the triangle. It's going to lie inside the triangle when it is an acute. It's going to lie on the vertex of a 90-degree when it is a right angle triangle. It's going to lie outside when it is going to be what, with an obtuse angle triangle, right? So these are the things which you have. Okay, so let's do it. Now, just see this. So we'll write it down. What are the points we have, right? Orthocenter, orthocenter lies inside the triangle, inside the triangle, inside the triangle for acute angle triangle, for acute angled triangle, right? Coming to the second point, orthocenter lies vertex of right angle in right angle triangle, right? Right? What is the third part? What is the orthocenter? Orthocenter lies outside the vertex, outside the triangle, outside the triangle for obtuse angled triangle, for obtuse angled triangle, right? Now let's do some questions on it. Okay. What are the questions? It says that how many altitudes can a triangle have? Altitude can a triangle have? Will what? 3. That's for sure. Question number 2. Will an altitude always lies in the interior of the triangle? If you think that need not to be true, draw a rough sketch and you can just prove it. Now you can just do this by yourself also, but still we have just shown you it's no, right? Because we've just showed for acute angle it's inside, for right angle triangle on right degree, for obtuse outside the triangle. Can you think a triangle of two altitudes of two in can you think of a triangle in which two altitudes of the triangles are the two sides, are the two of its sides, which is what better? Just now you saw that in right angle triangle. Just now you saw that in right angle triangle, this is going to be a 90 degree for this side, right? For this vertex, if you're going to draw this A, B, C. From vertex C, this is what BC is the altitude. From the vertex A, AB is a altitude, right? So this is what altitude, right? Altitude, and this is again an altitude, right? So we can say this is for what better? Right angled triangle, right? Right angled triangle, right? Now just see the fourth part. What the fourth part says, can an altitude and median be the same for the triangle? Yes, it can be same only for, yes, it is same only for equilateral triangle, right? In isosceles triangle, there will be only one specific median and the one specific altitude is going to be same, but the rest of two are not going to be the same. That is why we say, yes, it is only possible, it is only possible in equilateral triangle, right? That's it. Equilateral triangle. Otherwise, no means no, right? Isosceles triangle, only specifically one, right? Not others. Now just see this. This is again a question. In the triangle, it says that in PQR, D is the midpoint. So it says that D is the midpoint means what? QD is equals to what, beta? DR, right? Can I say that half of Q of R? And can I say that PD is what? A median? Yes or no, right? If it is going to be joining on the midpoint. And PM is what? It's just going to drop 90 degrees. So PM is what? An altitude, right? Altitude, right? Altitude, and PD is what? PD is what? Is a median, right? Now it says that QM, the QM length upon is equals to what? MR length? No, because D is the midpoint, not the M. So it's no, because D is the midpoint of QR, right? Coming to the next part. Now, what do you mean by an incenter and the internal angle bisector? Now just see. What happened now if you take a triangle, right? If you take, what do you mean by an angle bisector? If you have this angle, right? Yeah, this is your angle and I'm making this angle as 72 degree. So if you draw a line like this is what? This angle is going to be 36 and this angle is going to be 36, right? So this line is what, beta? Angle bisector. Yeah, this is called what, beta? Angle bisector. Right? What do you mean by angle bisector? It means what? That is a line which divides the angle into two equal halves. That is known as what angle bisector is, right? Now, what do you mean by angle? Now, it says that the incenter of a triangle is okay. So, what is an incenter? That is, I'll write what is an angle bisector first. What is an angle bisector? It is a line. It is a line which divides. It's a line or a line segment, whatever you feel like. It is a line which divides the angle into two equal parts, into two equal halves, you can say like this. So let us suppose you have a triangle, right? What do you mean by now incenter? Now similarly we have learned about, like, we have just studied about the median, we have just studied about what beta altitudes. So in this again you're going to have an incenter, right? So you just see this is A, B and C, right? Now if you're going to draw an angle bisector, I'll draw one by one, right? So you draw this, so this is what beta, B by 2, half of it, right? Now let's draw the other. Okay, I'm drawing this as C by 2. Yeah, this is going to be C by 2 and this is going to be C by 2. Now I'll draw the other last one. Now from the angle A, I'm going to draw this as this. This is going to be A by 2 and this is going to be A by 2, right? So here this line where they meet, right? This is called beta what? An incenter. This is called what? Beta incenter. That is the point of concurrence of all the angle bisector is known as what? Beta incenter. I think so there's a very big line written over here, but I'll tell you in the easy way, right? So what happened? I think so. The figure is made very clearly over here. You just see this. They have just made the angle bisector like this, and then like this, and like this. So we see that the point of concurrence. This is what an angle bisector, right? Angle bisector, right? This is what an angle bisector, right? And this is going to be what beta an angle bisector, right? That is point of concurrence of all angle bisector is called incenter, right? This is the first point. The second point, what it is denoted by capital I, right? So this is what capital I, right? Okay. There are three angle bisector in a triangle, right? In a triangle, right? Now, what is the second thing that you want to know? What do you mean by internal? Like in center, you got what is an incenter? What happened with the incenter? What happened? Like if you take incenter, I'll take a green color and just explain it to you. From incenter, you drop a 90-degree, right? You drop a 90-degree. And basically what happened in CBSE, we don't teach this construction, but this construction is there in the ICSE in the class 10th, right? So if you drop from incenter, again, you drop this perpendicular and again you drop this perpendicular from here, right? Now what happened, these perpendicular lengths are actually the same. So that means what, if the lengths are same from a point, then a circle is drawn, and circle which is being drawn is called as what beta? This is called in circle. So what happened, from every incenter you draw a perpendicular, and this what happened, I'm not going to go in the proving part because there are some stuff that you should know about it, so I'm not going deep into it. So first try to understand this thing, that if you're going to draw the perpendicular from the incenter and then taking this point, and these perpendiculars drops on the sides are actually equal, right? These are equidistant. So we say that this is equals to this. So from a point that this distance, and this distance is equal. So this is going to forming a what? A circle or not? So what it is written, just read it out this thing. It says over here, okay. Now it says that in center of a triangle is us is in center of a triangle is us. My bad, sorry. In center of a triangle is a triangle center, and a point defined for any triangle is in the way that it is independent of the circle placement or the scale. Don't read this much. This is too much. I think so. I should erase this thing. Right. Hold on. There's no need to read this much. This is too much for you people. The incenter may be equivalently defined as the point. Now you just read it out. This incenter may be equivalently defined as the point where the internal bisectors of the triangle crosses, as the point equidistant from the triangle sides, or as the junction points of the median axis and the innermost point of the graph by transform to the triangle as the center of the point in fact. So this is going to be a big thing. So you just read it out. This thing, what I wrote. So if you're just going to drop, I'll write it down for you. If you drop a perpendicular, if you drop, I'll write, drop a perpendicular, I'll write it for you. That's a very big line. Perpendicular from incenter to the sides are equal. Yeah. Now, taking incenter as center and the perpendicular distance as radius, perpendicular distance as radius, draw a circle, which touches the sides, and this circle is known as encircle, right? This is known as what, beta? Encircle, right? So now I'll show you the video of the encircle also, right? Just see over here, beta. See that encircle is what? You see that the circle is what, beta? Inside the triangle, right or not, right? Okay, so it is also known as what? As inscribed circle. It is the largest circle that will fit inside the circle, and each triangle's three side is a tangent to the circle. So I'll write it down for you. It is also known as what, beta? Inscribed circle. I'll write it for you over there. So you just see that if the triangle is acute, still the incenter lies inside the triangle. If you're going to make this as a right angle triangle also, this is going to lie inside the triangle, right? This is going to be like somewhere it look like 90 degrees, right? Yeah. Now, if you're going to make an obtuse angle triangle, still this is going to lie inside the triangle, right? So incenter always lies inside the triangle, right? Okay, so what we see now, just write it down, this thing over here. Yeah, so I'll just copy this. Okay, just see this. Okay, so it is also known as what? Tangent. And one more thing, that is incenter always lies inside the triangle, right? Incenter always lies inside the triangle, right? So that's all for this thing. Okay, now coming to the third thing. What do you mean by the circumcenter and the perpendicular bisector? Okay, now let's see this. Now, what happens if you have the line segment, right? So what do you mean by first let's learn what do you mean by perpendicular bisector. So it means what if you're going to make a 90 degree from here, and let us suppose this length is what, beta? 10 centimeter, right? So if I'm naming this as D, so AD is what, beta? 5 centimeter, and this is what, 5 centimeter, and I'm naming this as E and F, right? So EDF is a straight line passing through AB and divides the AB into 2 equals half and making a 90 degree with each other. So from here what we get, so we say that AD is equals to what, beta? DB, right? And we say that AD is perpendicular to what? AB is perpendicular to what, beta? EF, right? Now, can I say that EF is what? EF is what? EF is dividing AB, not AB is not dividing EF. EF is dividing AB. So EF is called perpendicular bisector. Perpendicular bisector of AB. Please pay attention to it. Which line is dividing the other line, right? So basically the perpendicular bisector is being drawn for the line segments. We don't draw for the lines, right? Because you need the 2 points, right? So you see that this is called perpendicular bisector. Similarly, we have a triangle also, right? So if you have a triangle and you draw the perpendicular bisector, so I name this as A, B, and C, right? If you're going to draw the perpendicular bisector, it's going to be somewhere here. It is not necessary that it is going to pass from the vertex A. Now, till now, we have done everything which has been like what, like opposite vertex to the opposite side, opposite vertex to opposite side. No, but in perpendicular bisector, it is not necessary that it is going to pass it from the vertex. This is only going to happen in the equilateral triangle, no other triangle, right? So just see that this is going to be 90-degree, right? Now, let's draw the other color, right? So if I'm going to draw this, this is going to be what, 90-degree, this and this is equal. I'll draw a single stroke. You will just don't get confused with this thing. I'll drop a single row. I'm just making a rough figure, right? So this and this, right? So I'm naming this as E, this as like this is D, this is E, right? Now just see over here. Okay, similarly, if I'm going to draw for the AC, right? So AC is going to pass it from here, right? So this is like this and like this. This is F. So this is equals to this 3 strokes, right? So this is again the point of concurrence you're going to get, right? You will still, in the 3 of the cases, you're going to get the point of concurrence, right? So what do you mean by this? From here in the triangle, we saw that BD is equals to what, beta DC, which is equals to what, half of BC, and this is what, a perpendicular line, yes or no? And I'm naming this as line L1. This is as L2 line, and this is what, L3 line, right? So can I say that BC is perpendicular to what, line L1, right? Similarly, AE is equals to what, beta? EB is equals to what, 1 by 2 of AB, which is equals to what? AB is perpendicular to what? Perpendicular bisector, basically line L2 is what? Perpendicular bisector of AB, right? Now, similarly, can I say that AF is equals to what, beta? FC is equals to 1 by 2 of AC. And can I say that AC is what, perpendicular to line L3, right or not? And similarly, like L1, L2, or L3 are what? Perpendicular bisectors of the respective sides. So can I say that L1, L2, and L3 are perpendicular bisector of BC, AB, and AC respectively, right or not? So what happens? So and perpendicular bisectors does not necessarily passes from the vertex. Only the median, the angle bisectors, and these altitudes are going to pass from the opposite vertex to the opposite side, right? Now what happened? What happened to the point, right? So the point of concurrence, we say this, the point of concurrence, again, you will have a point of concurrence. So we say that the point of concurrence, a point of intersection, concurrence is called it's called circumcenter. It's called circumcenter. Circumcenter, right? Again, you're going to say circumcenter, right? In a triangle, how many angle bisectors are there? So in a triangle, there are 3 angle bisectors, right? So once you see this, that the angle bisectors for the different triangles are going to lie. Now just see, I'll just show you the figure. As we have learned that the altitudes, that is the point of concurrence of all the altitudes, that the orthocenter is not definitely going to lie inside the triangle. Similarly for this also, you just see this. I'll just show you the video again. Okay. Yeah. It says that a circle which passes through all the 3 vertices of a triangle is called what, beta? A circumcircle. Now, what happened later on, you'll be learning everything. Now, just see this. This is what a right angle triangle, right? So, what happened with the right angle triangle? This is what, sorry, this is an acute angle triangle. So, acute angle triangle, the circumcenter is going to lie inside the triangle. Now, let's make a right angle triangle. Just see this. Let's make the right angle triangle somewhere. Yeah. No, this is not right angle triangle. Yeah. When it is a right angle triangle, it means what? The circumcenter is going to lie on the midpoint of the what beta hypotenuse, right? Yes, sub proving it. Everything is what beta correlated, right? So this is going to be what? The circumcenter is going to lie beta on the midpoint of the what hypotenuse, because later on you will be learning that AC is going to be the diameter and angle B is 90 degree. That is why that is known as the center of the circle. Now let's make an obtuse angle triangle. Just see, it is going to lie outside the circle, right? Outside the triangle, right? Now, what happened? It says that a circle which passes through all the three vertices is known as what beta? Circumscribed circle, right? So let's go on this part, right? Now, what happened when you have drawn this? When you draw this, now later on, I'll just draw a new figure. I'll just draw a new figure. Just see over here. Yeah. My circle is going to be very bad, so let's make a small only figure. Yeah, it is right. So let us suppose this is the perpendicular bisector of PC, right? This is going to be the perpendicular bisector of EB, and this one is going to be the perpendicular bisector of PC, right? So this is D, this is E, and this is F, right? Now, this is called as what beta? Circumcenter. Now, I write it this circumcenter is denoted by O, right? Now, with this O, what happened later on? You will be doing the proving that with this O, you will do the proving that O length you will do like later on with proving you will see that OA length is equals to what beta? OB length is equals to what beta? OC length. So you can draw a circle like this. Yeah, my circle is very bad. It's like oval. So you will see that what is known as what beta? Now just see this. Okay. I'll just color this yellow color. Just see. The circle which passes through all these three waters is known as what beta? Circumscribed circle or circumcircle. This circle is known as what beta? Circumcircle, right? Circumcenter I wrote. Circumcircle. Circle, right? Now just see this one more thing. Now we'll write this. That is circumcenter. Circumcenter lies inside the triangle for acute angle triangle, right? For acute angled triangle, right? So link is there. You can always just check it out. What are the links? So you can just check it out. Okay. And circumcenter lies on the midpoint of the hypotenuse, I think so. You might be feeling very bored. It's going to be too much for class 7th grade. But yes, it's a little bit too much on the higher end, but this is going to be a very fruitful thing once you understood this thing. Okay. The circumcenter lies on the midpoint of what beta? Hypotenuse in right angle triangle, right? In right angled triangle, right? Now, coming to the third part, the circumcenter lies outside the triangle for obtuse angled triangle. For obtuse angled triangle, right? So this is for all we have. So hopefully you have understood like today what we have done the discussion. We have discussed about like medians, then we have discussed about the altitudes, then we have discussed about the angle bisectors, and then we have discussed about what beta perpendicular bisectors, right? So let's do one questions. I'll be telling you this thing. Okay, let's do one question, just one or two, not more than that. Okay, I'll ask you questions. Yes, I like color. Okay, just see this. It says that in triangle ABC, this is how the question comes. D is the midpoint of BC and G is the centroid of the triangle, right? If GD is equals to 2 centimeter, then the length of ED is what? Now, if you don't know what is like centroid divides the median into what 2 ratio, what 3. So it says that this is what ABC is a triangle, right? ABC, let me change color. Then I'll explain it. ABC is a triangle and D is a midpoint of it, right? And G is what? A centroid. We have learned that the GD, this is GD length is equals to what? Beta 2 centimeter, right? So 2 centimeter, and this is what? GD will be what? We know that centroid divides the median in 2 ratio 1, right? So what happened? We say that GD is what beta 1 part, right? And AG is equals to how much beta 2 part? Yes or no? So 1 part is equals to how much beta 2 centimeter and 2 part will be how much beta 4 centimeter. So AD length will be how much beta AG length plus GD length, yes or no? Which is equals to 4 plus 2, which is equals to 6 centimeter. That's it. See, these type of the questions which will come in front of you, right? So I'll give you one more. Yeah. Triangle ABC is a right angled triangle, right? Is right angled triangle, right? Right angled triangle at B, right? The circumcenter lies where, right? The circumcenter is where, right? So right now, just now we studied that in a right angle triangle, right? So in a right angle triangle, the circumcenter, this is B, this is A, and this is C. In the circumcenter lies on the midpoint of the what? Hypotenuse, yes or no? So you will be writing this word beta midpoint of AC. That's it. That's your answer. That's it. That's all you have to do. Okay, so one more thing, right? Like this, all these 3 points that this is important, right? Uh, that is the point. We say that in equilateral triangle, the centroid, median, orthocenter, and circumcenter, in center, all are the same, right? You can say like this. That is the point of. We say that especially only in equilateral triangle. So in equilateral triangle, in equilateral triangle, we say that centroid, orthocenter, circumcenter, and incenter lies on the same point. Like they all are same. They all are same. That's it. So hopefully, beta, you have understood this thing very well, right? So today let's have a quick revision for the things which we have done the discussion. What are the things we have discussed? We have discussed about today alt medians. point of concurrence of median is what beta? Centroid. Then we have discussed about the altitude. The point of concurrence of altitudes are what beta? Orthocentre. Then we have discussed about the angle bisectors. The point of concurrence of the angle bisector is what beta? Incentre. And that from the incentre, if you drop a perpendicular to the opposite sides, all the perpendiculars are what beta? Equal, and then they form a circle. And these circles are what beta? That is the largest circle which is fit inside the circle. Triangle is known as what beta? Encircle. Then we have learned about what are the perpendicular bisectors, and there are the three perpendicular bisectors in a triangle. And then with the point of concurrence of the perpendicular bisector is known as what beta? Incentre. With the incentre, if you just drop a line from this, you take the line from the circumcenter. If you join the point to the vertices, these lines will be what beta? Equal, and then you draw a circle, that is what beta? Circumscribed circle. So today we have done this much, and hopefully, I know this is going to be a too much for you, I know, but try to understand at this level, right? So this is going to be helpful for your competitive, more of your competitive and less for your CBSE, right? So thank you class so much. And if you have any doubt, please ask your doubts on your BDF and ask your doubts with your respective teachers. Stay well, stay safe. Bye-bye.